As a technician, IT support, or engineer, there will often be times where you're handed a cable that has no connector on it, and you'll be asked to add the appropriate connector to the end of that cable. This might be a coax cable, it could be twisted pair, or it might be fiber. For copper connections, we would commonly use a tool like this one, which is a cable crimper. This is a specialized tool that allows us to pinch the end of a connector permanently onto that particular cable. For example, it's common to use a crimper when you're connecting the RJ45 connector onto a twisted pair cable. For twisted pair wires, the connector itself pushes through the insulation around the wires to connect directly to the copper that's inside. For example, here is an RJ45 connector before it has been crimped onto the cable. You can see that the copper connectors are sticking up just a little bit, and notice they are very pointy at the ends. That's that pointy end that presses through the insulation and makes its connection with the copper inside. Here's what that same connector looks like after crimping. You can see it's been pushed into the connector and it is going into the wire that is now connected inside of that RJ45 connector. Notice that it also pushes in a cable stay farther down the cable so that it won't easily be pulled out of that RJ45 connector. If you're planning to crimp your own RJ45 cables, you'll obviously need a very good crimper, you'll need a set of electrician's scissors or cable snips, and you may need a good wire stripper to remove any of that excess cover from the outside of the cable. At first, when you try to do this yourself, it may take quite a bit of time as you're trying to determine the best process to use to get all of the wires in the right order and get them properly pushed into the connector. But once you do this a few times, you'll find the process is relatively straightforward, and that means that you can create your own custom length cables with your own crimper and your own RJ45 connectors. Instead of dealing with wires, why don't we connect to the network over a wireless connection? Obviously, wireless does have the advantage of not dealing with any wires, but there are also a number of issues and challenges with managing a wireless network as well. One of the ways that you can analyze the health of your wireless network is with a Wi-Fi analyzer. This can provide you with information on the frequencies or channels that are currently in use on your network and the networks around you. You can see the signal strength that you're getting from your local access point. You can see any interference that may be occurring across this network, and you can see all of the wireless devices that are communicating to your access point. If you want to get more detail about what specifically might be using the frequencies around you, you might want to use something like this, a spectrum analyzer. This is able to look at the entire spectrum and show you not only the 802.11 network that's in use, but any other frequencies in use by other devices in the area. Here's an example of the output on a simple Wi-Fi analyzer that's looking at my wireless network. If you're far away from the access point, you may find that the noise on this network is very comparable to the amount of data. This means that we probably are not going to have the best throughput on this wireless network. As we get closer to the access point, you'll find that the signal strength gets much stronger and you're able to visually see that difference in the Wi-Fi analyzer. One challenge we have on very large networks is being able to find the two ends of the cable, especially if you're dealing with hundreds and hundreds of wires on the floor of a building. One of the ways that you can track down the ends of these wires is by using a tone generator. This is really two different devices. One is the tone generator itself that you plug into the wire, and it puts an analog sound onto the wire itself. We obviously can't hear that sound with our own ears, so we need some type of inductive probe to be able to find that sound, even though we're not physically touching the copper inside of the cable. This means if you have hundreds or thousands of cables inside of a closet, you can use these tools to be able to easily find the end of any one of those wires. We would first connect our tone generator to the wire itself. This can be through a modular RJ45 connection. This might be a coax connector, or you might be plugging directly into the punch tone block. You would then use your inductive probe to move from wire to wire until you find the wire that makes some noise. If you are running a lot of cables in your environment, you're probably terminating some of them onto a punch-down block. This is a punch-down block very similar to what you might find on the back wall of a data center. We might be bringing in hundreds or thousands of cables and terminating them on these punch-down blocks to make the process of cross-connecting those cables much easier. This will individually connect all of these wires into the punch-down block and fasten them so they won't be easily pulled out. These tools also trim the wire once you punch them into the block, making for a very clean installation. Here's an example of a number of wires that are punched down into a punch-down block. You can see this is a twisted pair wire, and you can see there are a lot of wires that you would have punched into one of these blocks. That's why we tend to have these blocks numbered so that we're able to reference where this wire is and where the other end of this wire happens to go. You can also tell that the person who punched these down did a very good job of maintaining these twists all the way into the punch-down block. Obviously, it's these twists that help us prevent any type of interference. So maintaining those twists all the way into the punch-down block makes for a stronger network signal. And of course, it's often good to document where this cable is going so that we know what number it's punched down into and we know where the other end of the cable is. That way, if we need to complete this connection into a switch or some other device, we can easily find the cable that we're looking for. If you're working a lot with cables, you're punching down wires into a block, or you're attaching your own connectors, then you probably want to use a cable tester to make sure everything has been wired properly on that cable. If this is a patch cable, we want pin 1 to connect to pin 1, we want pin 2 to connect to pin 2, pin 3 to connect to pin 3, and so on. A cable tester is perfect for checking that continuity between all the pins and ensuring that we really did connect the right pins on both sides of the cable. This can also help us find any pins we might have missed, or if we happen to accidentally cross a cable, we'll see that in our cable tester. Cable testers are usually simple continuity tests. They're not providing any type of quality signal testing, but they do provide us with a quick way to know if we're wiring things the proper way. The tone generator and inductive probe I used earlier also double as a cable tester. I have the tone generator set into cable testing mode, and it's flashing to tell me that it doesn't see any wires because I don't have anything currently connected to that device. I'm going to plug in a cable into one end of this cable tester, and we'll plug in the other end of this cable into the other end of this cable tester. What we're hoping to see is a continuity test from pins 1, 2, 3, 4, 5, 6, 7, and 8, and you can see it cycle through each one of those wires. If these wires were not connected, then we would not see a light for that particular pin. And if it was connected to a different pin, we would see the lights jump around as it went through its test. It's a relatively simple test, but it can tell us very quickly if we were able to put the wires in the right order when we put on the connector. One challenge you often run into is that some equipment may show that there is a number of errors on a particular link, but you don't know if the errors are being caused by a bad cable or if the problem is within the hardware itself. This is where we would use a loopback plug. Loopback plugs are very useful for testing the physical interface on a device. There are different loopback plugs for serial connections, RJ45 connections, or even fiber connections. These are not crossover cables. They are a cable that effectively loops back into itself. To use these, we would plug one into the interface on a device, and then we would put that interface into a diagnostic mode. That diagnostic mode sends information out of the interface, and then it looks to see if any of that information is being looped back into the receive part of that interface. If everything is working properly, then the information we receive should match the information that we're sending. If we see any difference between the information sent and the information received, then it's very possible that we have a problem with that physical interface. And eventually, you may be tasked with gathering packets directly from the network. And there are a number of different ways to gather those details. One way is to use a physical tap. We break a connection and put this physical tap in the middle of the network link. Obviously, this is not something you can commonly do during production hours on a production network, but if you know that that particular connection will be used often for packet gathering purposes, you may want to install a tap there permanently. Many fiber taps tend to be passive taps, which means they don't require any power. Other taps may require a power source, especially if you're dealing with a copper tap. If you're not able to disrupt the network communication by installing a tap, you might want to use functionality that may be built into your enterprise switch. This is referring to a port mirror. Sometimes you'll hear this referred to as a port redirection or a SPAN. That stands for a switched port analyzer. With this port mirror function, you would plug in your network analyzer to one interface, and you would tell the switch to take everything from another interface and copy those frames into this protocol analyzer. This allows you to get a copy of all of the network traffic without having to put a physical tap in the middle. You're effectively using the capabilities of your switch as your physical tap. Here's a copper coax tap. You can see on one side is the network connection. On the other side is the equipment connection. Normally, these would connect from receive to transmit and transmit to receive. But with the tap in the middle, we would take one of those connections and put it through the tap. Then we take the other direction and also put it through the tap. Now that we've tapped that data, we can connect a monitor or protocol analyzer and be able to get a copy of everything sent over those particular links for analyzing